All right, here comes problem number 2. I went ahead and entered it into my graphing calculator because it says use your graphing calculator. So I put in this equation. The first question says find the value of p. Okay, let's see what's going on here. So I have my function. The following diagram shows part of the graph. And p, notice p is that x-intercept. So there are x-intercepts at x equals 0 and x equals p. There is a maximum at a, where x equals a, and a point of inflection at b, where x equals b. Find the value of p. So find the value of p. So p is going to be the x-intercept over here. So let's go ahead and graph it. And where is it? I'm waiting. Bam. So p is going to be right there. So I can use my second calculate, and that's going to be a 0. It's an x-intercept. So I can go to the left bound, and I can go, what am I doing? Clear. Try that again. I want the x-intercept. Second trace, I want the 0. I'm going to go to the left of it, go to the right of it, hit enter, and it tells me that it's 2.73 and 0. Okay, so p, this lowercase p here, x equals p, p is equal to, what did I just say, 2.73. Okay, and I used my graphing calculator to find that. Okay, so let's see, how many marks do they give me for that? Oh, they say 2 marks. So if I want to do that, how can I show that? So basically, when you're using your graphing calculator, you should basically sketch what you're seeing, and then finding that. So 0 on Calc menu. All right. Write down the coordinates of A. So now it says to write down the coordinates of A. So again, I shouldn't have to do any work, but there's no numbers on the graph, so I am going to have to use my graphing calculator. A, they tell me, is a maximum, so I can go ahead and use my Calc menu again, and I'm going to do maximum, and I want the left bound, so let's go over to the left, go over to the right, hit enter, and I get the coordinates of A. I get 1.88 and 8.12. Okay, write down the rate of change of f at A. So to find the rate of change, I'm going to use the derivative function on here. So that's dy dx. So I'm going to select dy dx. Oh, I got a lot of glare on that. Select dy dx. And then I have to put in what value for x do I want. I want 1.88 because I wanted a point A, so 1.88. Oops. 1.88. Actually, why am I doing this? This is kind of dumb. It's 0, right? Okay. A is a maximum. What's the rate of change at a maximum? Well, it has a slope of 0. So that was silly. I did not need my calculator for that. So this would be the rate of change. Write down the rate of change of f at A. That's the same as the derivative. What does it equal there? It equals 0. The rate of change is 0. Okay, or you can say m equals 0, however you want to say it. All right, find the coordinates of B. B is an inflection point. My Calc menu is not going to get me an inflection point. So I need to take another derivative. Okay, so I can use the first derivative, or I can go ahead and take the second derivative to get the coordinate of B, or actually get the x-coordinate of B, and then I'll have to plug it back into the original function to get the y-coordinate. Okay, so find the coordinates of B. So if I take my original function and I take the first derivative, so looking at my original function, I'm first going to take the first derivative. So I have 4 times negative 0.5, that's going to be negative 2. So negative 2, x to the third, plus 2 times 3 is 6x, plus 2, there's the first derivative. The second derivative is equal to negative 6x squared plus 6. So I can actually do this with either either derivative. I could use the first derivative and use my calculator to figure out where the maximum and mins are of the first derivative. But I'm going to go ahead and just, since it was easy enough to take the second derivative, I'm just going to do this by hand. So I can use the second derivative to find the points of inflection by setting it equal to 0. So negative 6x squared plus 6 is going to equal 0. That'll get me the points of inflection. So I'm going to add 6x squared to both sides, divide both sides by 6. X squared is equal to 1, square root both sides. I get x is equal to plus or minus 1. Now, notice on the graph, the point B is in the first quadrant, so therefore I only want the positive answer, so x is equal to 1. So here at B, x is equal to 1, but now I need to figure out what's my y value. So I'm going to plug in 1 back in here, but remember I have this in my calculator. So if I go back to my calculator, make sure I still have it in there. Yep, I have it in there. So I can actually use the calculate menu, say value. I want to know when x is 1, what's y? And there it is. It's 4.5. So I didn't have to do all the heavy-duty lifting of calculating. I could just put it into my calculator, and I get 4.5. Okay, so what I did is I used f of x, what I actually did, I did f of 1. F of 1 is equal to negative 0.5, 1 to the 4th, plus 3 times 1 squared, plus 2 times 1. But rather than typing that all in again into my calculator, I just used the value function on my calculator to get 4.5. All right, find the rate of change of f at B. Okay, so again, I can go back to my graphing calculator, or I could use the first derivative. So the first derivative gives me the rate of change. So I could do this. I could say, okay, what is f prime of 1? So I could do this by hand. I could say, what is negative 2 times 1 cubed plus 6 times 1 plus 2? So 1 cubed is 1, so that gives me negative 2 plus 6 plus 2, which is equal to 6. So if I go ahead and check that on the calculator, I could also do it on the calculator. Let's see, get the glare off of there. I could do second calculate and ask for the rate of change, derivative, the rate of change, which is number 6. And then what value do I want it at? I want it when x equals 1. So I type 1 and hit enter, and it also gives me, oh, wait a minute.